Thank you all for coming today. I wanted to tell you a little bit about something that I call lean threat intelligence. First of all, I have to say that this is something that I came up with together with a user of Graylog. I'm going to tell you more about that later. That's Zach Allen of the Fastly security team in San Francisco, the CDN over there. So he originally he came up with the term of this, and we kind of worked on this together, and we evolved this idea a little. So this is not only my idea, but it comes from working with computers and the internet and security and programming and architecting and stuff like that. It feels like after a few years of doing that, it kind of all came together a little, and I felt comfortable doing something in the room of or in the context of a security conference now, because my background is not necessarily cybersecurity or security or incident response or anything around that. My background is more that I was a software engineer and a software architect. So I come from the DevOps world. I started writing PHP ages ago in Germany, then did some Ruby, and I started working on Graylog, and more and more people started using it for security use cases. So then I kind of had to get into the whole security space. So I guess many of you will know more about certain security use cases than I do, but I've been talking to a lot of users and customers and people in the security space, and I've seen a lot of things. I'm trying to get this all together, which is also, I'm planning a pretty long Q&A session today, because maybe there's even a way to get a discussion about this going. What struck me was that when I started as a software engineer, this whole idea of, you probably heard about it, DevOps, really just started to come along, which is there's developers and there's operations people, and they kind of, it feels like they're working all against each other all the time, which means the developers write the software and the operations people have to run it in production, and they complain that, developers complain that operations is not fast enough and they can't get their hardware fast enough, and there are all these processes of making sure the software actually runs, and the IT ops people then complain that the developers write this stuff but don't think about how to deploy it and configure it and how to run it in production. So this DevOps idea came together of, it's kind of both worlds. So you write the software, you deploy it yourself with help from IT operations, but you're more involved to understand what each other's problems are. And when I came deeper into the security space, I felt like there's similar problems. There is security analysts who look at data that maybe other people collect, and I was in the office of a user, and I saw people line up at the desk of the poor guy over there who was running the log management system, which I think was Splunk back then. And we're asking for, hey, can you put this new rule in? And hey, I need to parse this. Hey, can you install this app for me? And I felt very reminded of the problems that I saw being a developer, having to work with IT operations. So that was when I started thinking about there must be a better way that we can maybe have a database layer of all security data that is a little more self-service, where if you need something from that database layer and you have access to it, you can just go in, you can subscribe to data many different ways. There's going to be APIs. There's a lot of runtime configuration that you can do in the web interface of this system without having to require restarts, which obviously comes with a lot of problems of you have to have the permissions, and if you make a change, that can affect other parts of the system. So this is when we started thinking about this more. I usually start a talk with asking who of you is doing any kind of log management right now, which means you're centralizing your logs in your organization somewhere. And who of you is using Splunk for that? And who's using something like the Elk stack, something from Elastic, for example? Okay, anybody who has heard about Graylog before? Maybe even a user in this room. And I'm just doing that to figure out what's going on. Okay, because I will focus the talk today, I will show you a bunch of stuff in Graylog. It's very important that you can do that with Splunk, you can do that with the Elk stack, you can do that with other tools too. I'm just going to show it to you in Graylog, because this is obviously the tool I know the most about, because I started it back in the day. Then I also started a company behind it, but I don't want to make this a vendor talk. I want to talk about the idea of lean threat intelligence from the Graylog examples, but I'm sure you can build this with other tools too. So I feel like the traditional solution for this is that you have a system, for example, a SIEM system, that is detecting threats mostly based on real-time data and also usually based on streaming data. So it's looking at shorter time periods, trying to build correlations. It's doing a lot of normalization, but it feels like it's not very flexible, it's very monolithic. And it usually comes with a standard set of logic-based rules from the vendor. And then you're with some tools at least, there's better examples, not so good examples. It can get pretty hard to write your own rules. You'll have these weird UIs or weird config languages behind it. And I've seen it a lot that people just stick with the rules that are in there, just let it run and hope. Depending on how good your security organization is, some people just make a checkbox on it and say, yep, seen, we got it. They also tend to be pretty expensive. And they also, this is my biggest problem, that was the reason I started Graylog back in the day. They tend to come with a really weird software license that can get in the way. So I don't know if you're using a scene or if you're using a log management product like Splunk, for example, that is restricting your use based on how much data you're writing into it per day. I think we've all seen projects at organizations where where a manager goes around and tells everyone to log less because we're approaching daily limit again. Which obviously is the exact opposite of what you want to do. So that can be a big problem in practice too. And if you want to log more for a month, for example, or if you are in any kind of e-commerce setting and Thanksgiving is coming up, it can be pretty hard to get like a license increase just for a month or something because then your manager got to call another manager who calls this Splunk sales guy, and so it takes forever. So we also don't want to have that, I think. But that's kind of the traditional solution that we see a lot out there. And I feel for this lean threat intelligence idea, there's a few requirements. When I say lean threat intelligence, this mixture of this process philosophy and also this idea of having a database layer that's very self-service and provides all the data in your organization that's related to security. What you need is something that is able to process large amounts of data from a variety of sources. And I see that this is usually the biggest problem already, which is how do I get this Cisco firewall log, the Cisco router logs that look like syslog, but it's really not syslog, so all of the tools out there fail when they try to parse it, except if you have the Cisco app, which applies some other parser on it. Or you have other vendors out there that will just send you the most bizarre XML-based whatever event logs, for example. How do I parse that? Now I've got to normalize it. You have to have a solution that allows you to do that very quickly. You have to have a very good ACL system, so access control list system, that allows you to give users different permissions, maybe based on roles, based on the LDAP group that they are in. Because this idea really lives and dies with how good are your permissions behind it. Because there is going to be, sooner or later, there's going to be some data in it that a certain team is not allowed to see. I come from a background of working in Germany for so long. There's such strong data protection laws that, for example, I was working as a software architect. I was not allowed to see certain logs until the last days of working at that company. Because they might include email addresses or IP addresses. And that is under German data protection law. It's not allowed because I could trace what a user did and who that user sent an email to. Can't see the content, but I would know that there was some metadata-based communication going on. So that is something that you will hit sooner or later, especially if you are in a world that has any financial data in their credit card numbers. You probably all see it. It has to have a real-time detection of threats, which is, I think, the classic, for example, an IDS system that looks at data and looks at this data stream the moment something happens, or maybe a few minutes after it happens and it did some correlation, it can tell you something just happened, something's going on. You want to look at it. But it also has to have the batch side of analysis. For example, if you imagine that, for example, recently when the FBI and DHS came out with this Grizzly Step report, we have a bunch of users who ran searches in Graylog over the last 5 months of network data to see if they got anything from these indicators of compromise and see if anything happened there. Turns out it was mostly Tor nodes and VPN, so they all had something, but that is something that you want to do that's not real time. So you need to have a copy of the data in an enriched and already parsed and structured format somewhere to make it available for search. You want to have some kind of enrichment of the data, because if you deal with only IP addresses all day long that has no context, like who is information of this IP address from which country it is coming, or which organization is owning that IP address at the moment. If you're working in a cloud environment, for example, you want to have an enrichment of this is the IP address, and the system saw that it's an internal IP address, and did an automated lookup in the Amazon APIs, for example, the AWS APIs, to figure out this is an EC2 instance, this is its description, and it's that security group, for example. If you can enrich data like this, you'll have extremely powerful searches and very, very good way and very easy way of doing incident response and doing threat hunting too. Has to have alerting, obviously, and very, very important, has to have powerful and very open APIs in your integrations. This is when, and that goes back to Zach from Fastly, they wrote a Python wrapper for the Graylog API, for example, where they can run their own searches, do a lot of searches and threat hunting and stuff like that on the command line. That is because Graylog is written in Java, and they don't do Java, or they don't like it, they don't want to write it. So just use the REST API and write your own Python script, or Ruby, or PHP, or whatever you prefer. For the architecture, like I said, software licensing cannot be in the way, I think. That's always going to, the moment software licensing is in the way, that is going to go up and up and up and up in your organization. It just takes longer and longer and longer, and the conversations get more and more awkward. I don't think that can ever be in the way. So you want to have a very open licensing, which is why what I'm going to show today is going to be based, and I'm going to have a demo right after this. It's going to be based on open source software. Sure. There's other integrations with proprietary software, but I can only highlight how important it is that software licensing is not in the way. Which is, I think, one of the reasons that tools like Graylog or Elk, or the Elastic Stacks, what it's called now, are so popular, because people feel liberated after they got it running, and they are not in this daily limit of log data anymore. Has to offer, like I said, stream and batch processing for real-time and aggregate analysis. Must scale very easily. The nicest or the best system doesn't help you at all if it's not able to process 500,000 of log messages per second, for example. If you have that many messages, but even if you have 5,000, 10,000, 20,000, if it's a pain to scale that thing, it's just not fun to run. And again, the operations people who have to run that stuff are going to hate you. It has to be able to enrich the data, like I said, good APIs and permission management, provide the data in a programming language agnostic way, so you don't have to write your own kind of weird internal system of rules that a vendor came up with, but something you can integrate with whatever you feel comfortable with, so probably Python. Must be able to act on events automatically. That means when something happens that you detected, send an email out, send a Slack message, PagerDuty, maybe even trigger a script and do something automatically. If something that you're so sure about is a bad thing that just happened, trigger an IP tables rule somewhere on your host. Should be possible. And it has to be able to mix together open source intelligence, like all the open source threat intelligence feeds out there, together with your proprietary intelligence, because I think the open source intelligent data feeds out there, like from Spamhaus and from Facebook Threat Connect and Alien Vault, Open Threat Exchange, and all that stuff, I think it's great indicators, but the moment you start using them, it's really just an indicator. There's going to be a lot of false positives, and most importantly, it's not going to catch anything that's really targeted on your infrastructure. So you want to combine that with proprietary intel. So if you, for example, have seen suspicious IP addresses before, where you thought, that's kind of weird, you want to keep an eye on them, so you want to mix that up with your own lookup tables, for example. So the goal is, and that's what I'm going to show you next, the goal is a self-service database layer for all security operations across the whole organization. And the solution diagram is actually pretty simple, I think. You got all of your, you have all of your log data from network hardware, applications, operating systems, cloud APIs, all the stuff that you're looking at that might have a security relevant signal in it. Send that through a load balancer or an aggregator. We see a lot of people have, for example, a Logstash or a FluentD, or an NXLog, which is a wonderful tool in the Windows world, sitting there combining all these logs and then writing them into a message queue or directly into a log manager. I'm going to show you with a message queue in front of it because that adds another level of flexibility. On this message queue, you can have very, very dynamic subscribers and other backends. That means your data is not going to be stuck in your log manager like Splunk, Graylog, Elk, Logarithm, whatever you want to use. But it's going to be available in a real-time stream through this message queue. So if you want to hook something else into it, like for example, write some stuff enriched into a Hadoop, or write it on file, or store it in Amazon Glacier or S3 or something like that, you have this very, very flexible point that you can hook in. And in this case, The solution that we see and that I feel most comfortable with is using Kafka as a message queue. Can be complicated to run. But if you play around with that, maybe leave the Kafka part out in the middle. You've got to run Zookeeper, and it's not the easiest system to run and maintain. And it's definitely going to require some reading to get that running. But if you have it, you can have this one. You can have an extremely flexible system where you, for example, have all of your normal log data, your syslog data from your network hardware, from your operating systems, Windows event logs, all of that stuff goes directly to Kafka. But you can also send stuff from Snort, from OSSec, from other proprietary tools out there that are doing some kind of analysis on the data already, and then send aggregated alerts into the system, like in this case, Graylog. So for example, if you have Snort in OSSec or other IDS logs, going into a system like Graylog, you can have this as kind of a high-level start if you want to do threat hunting or just a general analysis of what's going on, and then later on do analysis and correlate that data with your NetFlow logs, for example, and see, okay, what exactly happened here. You want to get all of this into one big bucket and have it all together ready for correlation. One specific thing here about Kafka, if you know how Kafka works, Kafka has a concept called partitions, and a partition is like, on a classic message queue like AMQP, for example, a partition is like a topic that you can subscribe to. So you would write all of your data onto a topic called raw logs or something that had no enrichment at all yet. And if you want to subscribe to that, you can get a live stream of all your logs and stream that on your terminal, for example, to do real-time analysis with a grep and a pipe and do all that kind of stuff. You can write it into Hadoop, do all of these integrations. But what we see what people do is they then write from Kafka into Graylog. Graylog does a bunch of enrichment of the data, like the stuff that I mentioned with look at the IP address and enrich it with information about the AWS entity that sent this, or do a LDAP lookup internally, for example, or some directory lookup internally to see, okay, this was my internal IP address, and this has the host name MySQL database 1, and it is in this configuration group, and it's in this data center. Do all these kinds of enrichments is something that you can do in Graylog or with a hook in Kafka. And then write it back from Graylog onto another Kafka topic and call it the enriched messages. So now if someone wants to subscribe to something in Kafka, you can go in and say, do I want the enriched messages that have all the data on it already, or do I want the raw messages that have not been parsed yet, basically just the bytes that came out of the network level from your other log sources. So with this combination, we even have people who write it back onto Kafka, do another analysis, and then write it back into Graylog again. That is stuff with the output routing that you can build. So you're extremely flexible, and people from the outside can hook into that at any time and get any kind of state of data that they want. And I am actually going to show you a Graylog setup in this case. That is set up like that. It's running in the cloud, it's running on, just so you understand what data it's seeing. It is collecting the AWS NetFlow data. So it looks very similar to if it was a switch or a firewall somewhere in your network. It looks just like that. It's going to give you high-level information of this IP address through this network interface connected to this IP address through this source port to this destination port, and it was accepted, rejected, was a TCP or UDP, basically. Very high-level information. And it's going to give you that together with enriched information. So it's going to do all kinds of threat intelligence lookups to see if this is a known bad actor. It's a good indicator. You shouldn't rely on it, but it's a good indicator, I think. And it's also going to do whois lookups and geo-IP translation of every IP address that it sees in there. So you'll see very, very enriched messages in there. It's also getting OSSec logs of a honeypot that we're running in a very isolated AWS environment. That is it's a completely open security group in Amazon is running a bunch of fake services and just sending all of the OSSec logs into Graylog. This thing is going to, because the IP address is out there for so long and that service is out there for so long now, that service is getting hammered with automated attacks. So that's generating a lot of data that you can correlate later on. And it's also, I think it's getting the access point logs of my access point at home through an SSH tunnel into that too, just to have another data source in between. And the first thing, I always start logged out to show you that you cannot do anything in Graylog And everything you see is the complete open source Graylog stuff. So if you want to play around with this, you can go to graylog.org and just download it and play around with it. Just the OPA image, you just want to spin it up. Should be fairly easy. It always comes with security enabled. We have the philosophy of HTTPS, SSL encryption of messages that are being sent into it, encryption at rest, LDAP integrations, all that stuff should really always be in the free version because we don't want to have a management decision or make a management decision possible where someone says, no, I don't want to pay for this, I don't want to pay for the security feature, so just run it, it's going to be fine, right? It's going to be fine, we don't need encryption. So this is always open source and in it from the beginning. I'm logging in here with an admin user. That's why you're going to see everything in Graylog. If you have another user permission, you will just not see certain links. If you have a user, for example, that's not allowed to start and stop message inputs, that's just not going to be in the interface. And the REST API call that's behind it will just return an unauthorized. So you can build this all very dynamically. Now if I sign in. And this is actually running, it says localhost, but that's just an SSH tunnel to the cloud. So this goes through the internet, and I pray for the demo gods today that this is actually holding up. And I usually start with the system area because this is showing you how all the stuff hangs together and it's showing you this first idea of everything should be self-service and never require a restart. Everything you do in Graylog specifically is when you set it up, you have a configuration file, the Graylog conf, which is a standard text file that has the base configuration of this is where my Elasticsearch cluster is, and this is my cluster name, and this is the IP address I'm going to listen on. Some base configuration that requires a restart. From there on, everything is done during runtime. So, for example, if you look at the nodes overview, you will see that we have one Graylog server running in this cluster. It's not really a cluster actually. We've got one Graylog server running here. You see that it's currently not getting any messages in. This is the stuff here on the top. This is simply because we're reading flow log data directly from Amazon, and that tends to push you just 25,000 messages in a second, and then it waits 30 seconds until it sends you more. So you'll see this jump up from time to time. That's simply how the Amazon APIs work. And you see that you got a memory overview here. If you click on the details, you'll see that we got all kinds of internal metrics here. This has been built because what we as a company do is we're selling support contracts for this. This has been built from the beginning to be very, very easy to run and maintain yourself because I actually don't want the customers to call me. So the cool thing is because that is open source, you get the same thing, right? So it's very, very easy to debug, I think. It's giving you a lot of internal information. And for example, if you had a slow rule somewhere, you would see that the process buffer here is going to fill up. And you'll see that messages get stuck there, and you can look into what exactly is going on there. And to show you the self-service approach here, you see that we got this inputs area here, where, for example, imagine that you want to collect syslog through TCP from your firewalls, for example. You would just select an input that you want to start, the input type. So you say, I want to receive syslog messages through TCP. Say launch new input, decide on which Graylog node it's going to run, give it a title, give it a port to listen on, the bind address, pretty standard, bunch of optional fields here if you want to do TLS encryption, for example, of the data that goes through. And if I was to press save here, if I was to press this button, that would trigger a REST request to the Graylog server and it would start an input right away. And you would have something listen on that port, point your firewalls there, boom, you're ready. So this is the self-service approach, and it's also a programmatic approach because everything you see in the web interface is actually just a REST request to the Graylog server, which means if you want to automate that, if you have a configuration management system, if you have something that you want to trigger from a script, you can do that because it's just API calls. And because the web interface is just a single-page JavaScript app, it has no actual logic in it, I would almost say. Everything that I'm going to show you here is in the end just a REST API call. Like all the analysis, creating streams, deleting streams, getting pivot values, that's all just simple REST API calls. And every call has a permission attached to it, and every user has a set of permissions. So you could even say this user is allowed to search, to execute the statistics analysis on a specific subset of data. You could give that permission to a user if you want to. And it's all, I think it's all pretty straightforward here. If you go to authentication, for example, you see that we got one that we got only one user installed here, but if you wanted to, for example, integrate with LDAP, put all of the LDAP integration in there. You can even do, and this is, I personally hate LDAP, and I would say I could configure it if I get it wrong about 50 times, and I figure out, oh, this weird OU string has to be this way, and there's some other configuration that I got wrong. You can actually do a login here. So this is something that we hear a lot from people. It's this tiny little feature, but you can set up everything, test the server connection, then do test logins, and it will say, yes, this user would have been logged in with this permission group, for example, and then save the LDAP settings. So I hope I can save people some pain by not having to restart the server for putting some other configuration into a configuration file. If you have any questions, by the way, you can also just throw them in while I'm showing something. But we'll have a good amount of Q&A time. Just quickly going to show you the pipelines. This is a feature that came out with the 2.0 version, which is a very dynamic way of taking log messages that are coming in after they have been separated by streams. I'm going to show you the streams after this, actually. But imagine streams are real-time categorization of messages. You can have a stream called firewall messages Cisco, and a stream called AWS flow logs, for example, or a stream with all your OSSec messages or all your DNS queries. Right, DNS queries is something I forgot to explain this. I'm also collecting all DNS queries that the server that is running Graylog is making. It's listening directly on the interface and searching for DNS traffic. You can put these collectors wherever you want to get an overview of all the DNS traffic that happens in your network, which means even if malware is using an external DNS server, so it's not in your logs, you can, if you put that at the gateway out to the internet, you'll get a list of everything that ever went over the wire, which is a different topic, I think, but don't be confused if you see DNS queries in there. And I'm just going to show you, for example, the OSSec pipeline, because OSSec is sending Ceph, the common event format, I think, which is good, which means all the fields are being passed automatically, are being parsed automatically by Graylog. But in this pipeline, I'm enforcing a unification of the fields, because I have decided that in this setup, the source IP address is always in a field called src_address, for example. Now OSSec is sending that in just a field called source. That makes correlation very complicated. You've got to think about if you build a query. So I'm having a pipeline step here. I'm having a rule here, which is taking every message that comes into the OSSec stream, checks if the message has a field called source, and then just sets the field source address with the value of the source field, and then removes the source field. So we have a unification of this, which is very, very important. Especially if you have different teams, it's very helpful to have kind of a style guide of saying, if you send something into this and it has a source IP address in it, please call it source_address. Or you'll get query hell and dashboard hell after it, especially if people change it later. Another thing that's happening here is that we are doing threat intelligence lookups. When we say that when a message has the field source address or destination address, we run a function called threat intel lookup IP to take the source IP address that's running in the background. It's heavily cached, so the first message that comes in might cause a little delay, but from there on it's heavily cached. It's doing all of the enrichment, which I'm going to show you in the messages actually in a second, and we're also doing whois lookups, which goes directly to the Aaron whois lookups. And I thought this is never going to work because of quota limits. For IP lookups, compared to domain lookups, the quotas are actually pretty low. So if you ever want to do that, if you cache it properly, they'll probably not even block you out for thousands of lookups a second. At least I was not locked out yet, and we have some setup with 25,000 lookups going in very fast.
For the thread function that you have in there, is that like predefined sources, or do you like add those sources?
Yeah, so right now it's predefined sources. It comes out of a plugin. So all the stuff that you're seeing here, that's actually plugin code. And that plugin's open source on GitHub. If you want to build your own, you can add it there. We're working on making that just a kind of a rule language, because these thread feeds usually kind of look the same, right? And there's also, I know there's Palo Alto Networks is working on this called MindMeld, I think, which is an aggregator. We're working on an integration where you can just say, this is the format, like all the commented lines are starting with a hashtag, for example, and then it's going to be an IP address and the script behind it, for example. You can also do known Tor exit node lookups, all this kind of stuff. And I felt like I've built 5 of those now, and it's almost all the same code except the parser. So it feels like you might want to unify that and open it up. Especially if that's what I mean with proprietary Intel, if you have your own lists, and maybe it's a CSV lookup table somewhere or a MySQL table or something, that would be very easy to do. Okay, so much for the system part. You see, there's a bunch more stuff here, like you can change log levels on the fly. You can manage index sets, but I think that's a little out of scope for today. So I'm just going to jump right in and show you some searches. I've never run Graylog on such a small resolution in a while. I hope, because I actually wrote most of the CSS in there, I hope it's not completely breaking. We'll see. So this is the general layout. And if you've ever used a tool that is working with logs, I think you might be fairly familiar with it already. You have a search query bar here on top where you can enter your search query. You're using the Elasticsearch search query language. So if you use an elk stack and you want to look at this, for example, it's going to be just the same query language. Big difference to Splunk, and you could argue if it's better or worse, or if there should be a way in the middle. You cannot do any kind of field detection or field transformation during search, except with decorators, but that's another topic. You will not see this very powerful pipe-based language that you see in Splunk. You have to transform the messages up front, and you also have to apply the format of the messages up front. So it's not a schema on read, for example. It's a schema on write in this case. Select a time frame, write your query. You can save searches. On the left here, you've got some information about your search result, how many messages were found. This is just every message in the last 5 minutes in this case. And you'll have this here on the left, which is a list of all parsed out structured fields of messages. And I'll use that in the next few minutes to do a little bit of analysis. But this is basically all fields that are appearing in this result set. So for example, if I click on a message, you'll see that this is, the message is that there was a DNS query for the Latin America NIC, which is a whois lookup that actually happened. Because I said it's the DNS logs of the Graylog server, so it's logging its own whois lookups in this case. But you see that we got this message here is broken down into a bunch of fields. So for example, DNS question type, the response code. You see that we requested the DNS question, so the host name that was requested for translation did not indicate a threat, so DNS threat indicated set to false. If this was a host that is known for distributing ransomware or actually displaying a ransom page, that would be set to true, for example. And then you could decide, do I want to get a nightly overview of all my users that got infected by ransomware tonight? Or do I want to get an immediate alert the moment that happens? This is the difference between doing something in real time or doing something on aggregated data. But you have this parsed out here. This happens the moment the message comes in. So you could act on it immediately within a few milliseconds of this happening in your network. And you'll see that these fields here, for example, DNS question or DNS question plus, are also here on the left in the sidebar. So all fields in this result set will be in that sidebar, which is very helpful for analysis, which I'm going to show in a second. And you can also build your own tables here. If you, for example, want to have more information, where's this address? Here we go. So if you want to build more information in that table, you can do that very easily. We don't do that for now. Then let me open another field that has even more enrichment. So let's look at, for example, and you already see it's all in one big bucket, right? We've got OSSEC alerts, we got DNS query information, and we also got, if we scroll far enough, oh, that's my, it's actually working. That's my access point at home, and we also got, searching for some netflow messages. I'm going to explain you what this is in just a moment. Here we got the NetFlow information. That is enriched with a lot of stuff. So in this case, let me find one that has external communication. This here, for example, you'll see that there was a rejected TCP connection from this IP address on this source port to this internal IP address on port 23, of course. And then you see that this has been enriched a lot. You see that we have, for example, Stuff that was not in the original message is, for example, the destination address entity. This is something that Graylog looked up in the AWS API. So you see this is an EC2 host, which is the Amazon virtual machines, and this is its ID. You see that the AWS type is EC2 and not, for example, ELB, which is the load balancer, or RDS, which is their databases. You see the name of that instance, which in this case is our ECS container instance, which in turn is the Amazon Docker service. You see that the destination address had no thread indicated. You see that the destination address is also an internal address because we have a pipeline step that looks at it and sees that 172.30 is most likely always going to be an internal address if you follow the RFC for that. And you see that the source address, because it's an outside internet address, also got translated to a geolocation. And you see that it had, and this is a bad example, we couldn't translate it to a who is country code and a who is organization, but maybe we'll find a better one. Here, there we go. For example, here is one of our internal IP addresses communicated out on the HTTPS port to a server owned by Google. And you see that here, destination address. There you go, destination address, who is information is Google. So this is what I mean with having this enriched data. This already gives you a good idea of what is actually happening in a very easy to use way, I think. Because if not, you'd have to open another tab, and you always look up and do this and do this and do this. By having this enriched information, you can just go in and say, show me of the last hour. Yeah. Show me all destination address country codes, for example. Quick values is going to build you a pivot table, and you see that 34.37% of all destination addresses were based in the United States. We've got some in Germany, some in France, some in I don't know. In Great Britain, Netherlands. You could go in and say, show me on a roadmap where all of those are located. Show me all of the source addresses on a world map, for example. So with this stuff and having all of this in one big bucket, I just wanted to show you one real world analysis, I would say. So imagine you're a security researcher and you see an IDS alert and you want to figure out what exactly is going on with this IDS alert. Now this alert could come from, because it's very high severity, you could get that as an email or some other way of notification. Or you could just see it by going into the stream that is selecting all of the OSSEC logs. Like here, if I click on show stream rules, you'll see that every message that contains the value of OSSEC post-intrusion detection system is going to be routed into that stream. So if I click on it, you now only have OSSEC log messages showed over the last 8 hours, for example. You'll see there's a lot of alerts going on because that thing's just out in the wild in the public. Then let's go in and execute a saved search to only show me the very high OSSEC events, which is, if I search for it, you see that I just executed a query that says, show me every message where the field severity is set to very high. This is a completely untuned OSSEC, by the way. I know that a user missed a password more than one time in an OpenSSH server is not necessarily very high, but let's imagine that we wanted to see where are all those very high alerts coming from. What was the source address that caused this OSSEC alert? Let's go to source address, run the quick values on it, and you'll see that we got a bunch of actually pretty active actors here. You see that roughly half of all very high alerts were caused by this specific IP address here. So let's go in, maybe even look at, we could now go in and say, show me all geolocations of that. Now we see this is where all of the high alerts were coming from. And this is always based on the result set, right? So if you dive deeper into a analysis, these visualizations will change with it and give you a very, very easy to follow way of seeing what's going on. But now let's say we want to investigate what exactly this IP address did in our network. Okay? So I just click the search button here. That's going to add this to the query, so you don't have to write it yourself. Execute this again. And now you only got all OSSEC alerts of a very specific source address. Now you can go in and say, actually, I want to see every activity in my network, and this is the whole correlation and this is the whole idea of having everything in one bucket and then do very, very easy correlations. By going back to the overall search, we're just going to search over the complete bucket of data in the last day, which is entering the IP address here. You'll see that now we got not only the OSSEC alerts, but we will also have, oh, sorry, let's search for it. Make it easier. Source address equals this. You'll see if we go to the source field and run a quick values on that, you'll see that we also got about 3,500 network connections. So maybe there was stuff that OSSEC didn't capture. So we can go in and say, show me all network connections of this source address. And you will see that, if I go to the destination address now, so where did this IP address in my network connect to? You'll see that it actually did connect to 4 different hosts. And you'll see that most of that, however, 99.68% went to this specific host. And we could now enrich that again and say, actually, I want to see what exactly that was. And you see, it did go against the honeypot, and this is where OSSEC actually caught it. But it also went to, it had at least one connection to a Graylog server, one to a load balancer, and one to I don't even know what host that is. Some other host. Actually 9 connections to it. And now you could do analysis of showing the destination ports and get a lot of context to it to then decide if is it worth it for me to go into, for example, the TCP dump and look what exactly is this IP address doing in our infrastructure. By having enrichment, like for example, we're working on something where you can have another enrichment that says, is this IP address a known public hoster, for example? Where we collect all of the IP ranges that are provided by Aaron, for example, take all of the IP ranges of Amazon, of Microsoft Azure, of GoDaddy, DreamHost, of all of those, so we can say, yes, this is this IP address came from a hoster, and it's a little weird that someone does something on our payment APIs acting like a browser or acting like a real user, but came from a hoster that might be someone who tries to hide his real destination and had a hop in between, for example. So with doing this kind of analysis, you'll get a very, very nice way of doing incident response and of looking at the data, and then from there on go deeper with what exactly you should do with this thread. And to go back to the easy integration, I just quickly wanted to show you, we're also coming to an end, 2 things, which is the API browser, which might need a moment to load with this. There we go. So this is all of the APIs that Graylog is opening for you. And this is only the top level APIs, where if I click on one, there's going to be several calls in it. So this is how you can integrate that with everything and really make it a database layer for your organization. Because with the rich information that I have, you don't even have to use the web interface. Maybe you want to use your own script that runs certain hunts for you that you can share with coworkers, writes it somewhere else, writes an email, does all kinds of integration. And if you want to play around with it, you can also just execute these calls directly from within the browser. This is Swagger, by the way. This is an open source project. That's great if you have any kind of API and you want to make a browser. We didn't build this part. And then you can also take that information and build the fancy dashboards that you can show your boss to show that you've got the cyber under control. Yeah, here for example, this is another case where we take the spam house, I think, ransomware block list, take the DNS requests and see if there's anything that's definitely known with a high chance to be involved in ransomware, for example. This is aggregate, but you could also go in and say, trigger something immediately that happens, do something about it. And then send it to you with the enriched information of, this happened on a workstation, and we already looked up that this workstation is currently run by a certain username, for example. So you know exactly where to now run to and pull the network and make sure nothing else happens there, for example. Yeah, that's my overview of Graylog. Like I said, this is probably going to work with a bunch of other tools out there too. I'm just most familiar with Graylog. And yeah, it's my first kind of idea and iteration of having a database layer and improve some processes in organizations. So I'll be around for the rest of the day, and if you want to talk about a bunch of other stuff, have ideas, have own experience with that, I'd love to talk. And I think we've got a few minutes left for Q&A if you have any questions. But Graylog, about this idea, about other tools. I've seen a lot of them in the work. Yeah.
Thank you for putting stuff out there. I used Graylog for the personal project years back where I was Graylog. What do you think architecture was the right person to have implement specific Graylogs? What could you suggest maybe like Robin, if you ever seen the concept of data lakes?
Yeah.
Suggest would be the architecture for that?
Yeah, I think I would go this, for example. I would, in that case, I would go with a Kafka architecture, because Kafka works great with Hadoop, for example. And then you can do this whole thing of you send raw data into Kafka, write that to Hadoop, or write enriched data back onto Kafka and write that into Hadoop too. So you've got both things. You know, the concept of a data lake is you have the raw data, so you can later on do other stuff with it. That is the flexibility of Kafka, or any other message queue. That allows you to store raw data in Hadoop and also the enriched data and subscribe to both and be very, very flexible. Yeah, we actually see it a lot that people write stuff into Hadoop too, because for some analysis, you're okay with it running for 30 minutes. It gives you like a really, really good analysis, which is something that Hadoop is definitely better for.
I was trying to calculate entropy of the network to see how
Yeah, exactly.
Thank you, Larry.
Cool.
Yeah. You have multiple search heads and multiple indexers, how scalable is Graylog?
I'll answer the question how scalable is Graylog, because multiple search heads sounds like you have a Splunk background, I think. So you can have, it has been built from the beginning to be horizontally scalable. We have a big US customer that we've all seen and all heard, and they have a huge environment. They're sending 750,000 messages a second, and that scales. They only keep it for a week, but they could keep it longer if they bought more objects. We're using Elasticsearch as a backend, but we use it differently than if you were just writing it into Elasticsearch and reading from it again, because we have the Graylog server in the middle that has a message journal sitting in front to make sure you never lose a message and buffer loads, especially load spikes back to Elasticsearch. But caching, dashboards work differently. So we use Elasticsearch differently, but I think Elasticsearch itself has proven to be fairly scalable. So yeah, we have, I've seen setups with about 60 Graylog servers, and then hundreds of Elasticsearch servers behind it. And I've seen some with just everything on one machine. It's wherever, whatever the architecture looks like, what you need. I don't want to miss you over there. Anything else? Yeah.
I guess I have another question, because this comes up with that quite technology related, but a lot of people at enterprises are reluctant to accept open source.
Yeah.
What's your argument for open source in the enterprise?
I think the biggest argument is that by having it open source, I mean, there's all the standard open source arguments, right? And I've seen a Splunk talk from their director of competitive intelligence or something. They are gonna, the moment you mention open source, there's a high chance they're going to send you a bus of consultants in that are going to scare you about open source and come up with like 90s arguments of it's going to be more expensive, TCO, and all of that. I think the biggest benefit is really in this particular use case for log management is that by not having a restrictive license on top of it, you can log whatever you want. And it's much easier to get more hard disk or maybe a few more cores and a little more memory than getting a bigger license for your proprietary tool, for example. And then it just comes with all this. For example, there's a bunch of stuff in this threat intelligence lookup plugin that is just coming from the community. So someone already built the MindMeld integration. That's just there. You don't have to wait for us. If you want to build it yourself, go build it. And then if people are reluctant because they say no one's supporting it and we don't really know and we can get indemnification and we want to redline a huge contract because that's how we buy internally, you can do that with us. And I don't want to go too deep into that, but if you want to, yes, we're going to provide support for it. Okay, if there are no more questions, I'll be around. And yeah.